Hello everyone, welcome to my comprehensive course on Angular. My name is Hasib. I will be your instructor in this course. I am a computer engineer and working as a web developer for a long time. In this course, I will assume that you are a complete beginner and by the end of the course, you will be a advanced level. Do you want to program like a professional program? This course will teach you step by step so that you can learn and understand Angular. Enroll now and get the opportunity to learn from this complete Angular course. Thank you for being with me. Hello everyone, welcome to the course. In this lecture, I am telling you about a fast Angular application. In this lecture, I am telling you about three versions of the Hello World application written in TypeScript ES5 and ES6. This will be the only section where you will see Angular application written in ES5 and ES6. All other code samples will be written in TypeScript. Now, Hello World in TypeScript. This first application will be quite minimalistic to get you quickly started programming with Angular. Both files are located in the Hello World TS directory in the downloadable code for the lecture. The index.html file is the entry point for the application. It will be contain references to the Angular framework, its dependencies, and the main.ts file, which contain the code to bootstrap your application. Some of these references can be located in the configuration file of the module loader. The code of the Angular framework consists of modules which are combined into libraries which are logically grouped into packages. Let's create an index.html file which will start by loading the required Angular script, the TypeScript compiler, and the System.js module loader. When the application is launched, the Hello World tag will be replaced with the content of the template from the annotation. Generated files are not committed into a version control system, and Angular 2 does not include ready-to-use bundles in its Git repository. They are generated on the fly and published along with the npm packages, so you can use unpkg to directly reference production ready bundles in HTML files. Instead, we prefer using a local install of Angular and its dependencies. So you will install them using nmp. Everything that is installed by nmp will be stored in the node underscore modules directory in each project. Now, content deliver networks. unpackage is a CDN for packages published to the NMP Package Manager registry. Check nmpjs.com to find the latest version of the particular package. If you want to see which other version of the package are available, run the nmp info package games command. Now let's create a main.ts file which has the TypeScript or Angular code and three parts. Number 1, declare the hello world component. Number 2, wrap it into a module. Number 3, load the module. You will implement this part in 3 separate files, but here for simplicity you will keep all the code of this tiny app in one file. Now, what is metadata? In general, metadata is additional information about data. For example, in an MP3 file, the audio is the data, but the name of the artist, the song title and the album cover are metadata. The MP3 player includes a metadata processor that reads the metadata and displays some of it while playing the song. In the case of classes, metadata is additional information about the class. For example, the add component decorator tells Angular that this is not a regular class but a component. Angular generates additional JavaScript code based on the information provided in the properties of the add component decoder. In the case of class properties, the add input decorator tells Angular that this class property should support binding and be able to receive data from the parent component. You can also think of a decorator as a function that attaches some data to the decorated element. The add component decorator does not change the decorated class but adds some data describing the class so the Angular compiler can properly generate the final code of the component either in the browser's memory or in the file on disk. Now hello world in ES5. To create application with ES5, you should use a special Angular bundle distributed in universal module definition format. It publishes all Angular APIs on the global ng object. The HTML file of the ES5 Angular hello world application might very useful. Because ES5 does not support the annotation syntax and has no native module system, the main.js file should be written differently from its TypeScript version. The first immediately involved function expression invokes the component and class method on the global Angular core namespace ng.core. You define the hello world component object and the component method attaches the metadata defining its selector and template. By doing this, you turn the JavaScript object into a visual component. Now hello world in ES6. The ES6 version of the hello world application looks very similar to the TypeScript version, but it uses Treasure as the transpiler of system.js. The index.html file. The only difference between the ES6 main.js file compared to the TypeScript main.ts file is that now you do not have the procedures name class member. And that's it, the hello world in year 6 I am now covering, and it is very useful for you. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about launching application. To run any web application, you will need a basic HTTP server such as HTTP server or live server. The latter performs live reloads of the web page as soon as you modify the code and save the file of the running application. If you use HTTP server, you will need to manually open the web browser and enter the URL http://localhost 8080, whereas live server will open the browser for you. To run the Hello World application, launch live server in the root directory of the project. It will load index.html in your web browser. You should see Hello Angular 2 rendered in the browser's developer tools panel. You can see that the template you specified for Hello World component becomes the content of the Hello World element, and the data binding expression is replaced with the actual value you used to initialize the name property in the constructor of the component. Now, the building blocks of an Angular application. I am giving you a high-level overview of the main building blocks of an Angular application so that you can read and understand Angular code. I am discussing each of this topic now. Now modules. An Angular modules is a container of a group of related component, services, directives, and so on. You can think of a module as a library of component and services that implement certain functionality from the business domain of your application, such as a shipping module or a billing module. All elements of a small application can be located in one module, whereas larger apps may have more than one module. All apps must have at least a root module that is bootstrapped during the app launch. ES6 modules just offer you a way to hide and protect functions or variables and create loadable scripts. Angular module is constant and used for packaging related application functionality. From the syntax perspective, a module is a class annotated with the ngModule decorator, and that can include other resources. Importing brush module is a must in the root module, but if your app will consist of the root and feature modules, the latter will need to import common module instead. Members of all imported modules are available to all components of the module. Your app modules can be loaded either immediately, as in the preceding code snippets, or lazily by the router. You will use @ngModule in every lecture, so you will have a chance to see how to declare module with multiple members. Now components. The main building block of an Angular application is the component. Each component consists of two parts: a view that defines the user interface and a class that implements the logic behind the view. Any Angular application represents a hierarchy of component packages in modules. An app must have at least one module and one component, which is called the root component. There is nothing special about the root component compared to other components. Any component assigned to the bootstrap property of the module becomes the root component. The selector property is similar to a CSS selector. Each HTML element that matches the selector is rendered as an Angular component. You can think of the add_component decorator as a configuration function that complements the class. If you look at the transpiled code of the main.js file from the listing, you will see that Angular compile did with the add_component decorator. For web application, a template contains HTML markup. You can also use another markup language for rendering native mobile applications provided by third-party frameworks. If the markup consists of a couple of dozen lines or less, we keep it inline using the template property. We did not use backticks in the preceding example because it is a single line of markup and does not contain single or double quotes. Now directives. The add_directives decorator allows you to attach custom behavior to an HTML element. Each component is basically a directive with an associated view, but unlike a component, a directive does not have its own view. To bind events to event handlers, enclose the event name in parentheses. With the input event occurs on the host element, the onInput event handlers is invoked and the event object is passed to this method as an argument. Directives can be attached to various HTML elements, and the constructor of these directives gets the reference to the rendered and the UI element injected by Angular. Now a brief introduction to data binding. Angular has a mechanism called data binding that allows you to keep a component properties in sync with the view. This mechanism is quite sophisticated, and I am telling you about data binding in detail. In this lecture, I am telling you about the most common to a value, a string in the temple. If you want to reference a DOM object property within the template, add a local template variable that will automatically store a reference to the corresponding DOM object and use dot notation. Now that you know how to write a simple Angular application, and that's it for the lecture. Thank you for watching. Hello everyone, welcome to the course. In this lecture, I am telling about JavaScript and TypeScript. The JavaScript language is managed through a standard process that defines new features. Modern browsers have started to implement features from the EC Mac Script 6 standard, and the Process for defining ECMA script 7 is underway as I write. The new standard broaden the features available to JavaScript developers and make using JavaScript more consistent with more conventional languages such as C# or Java. Modern browsers update themselves, which mean that a Google Chrome user, for example, is likely to have a recent release of the browser that implements at least some of the most recent JavaScript features. Sadly, older browsers that do not update themselves are still in widespread use, which means you cannot rely on modern features being available for use in your application. There are two ways to approach this problem. The first is to use only the core JavaScript feature that can rely on being present in the browsers that your application targets. The second is to use compiler that process your JavaScript file and convert themselves into code that can run on older browser. Now using classic JavaScript for Angular. You can write Angular application using just the JavaScript feature that work in older browsers without needing to add the additional step of using the TypeScript compiler to process files. The problem with this application is that it results in code that is difficult to read and difficult to manage. There are some recent JavaScript features that simplify the way that Angular features are defined and applied, and one feature called decorators that is essential for effective Angular development, but that is only a proposal for the JavaScript standardization process that is not supported by any browser. My advice is to embrace the complete Angular experience, even though it can take some time and effort to master the new JavaScript feature. The result will be a better development experience, concatenating code that is more concise, easier to read, and simpler to maintain. Now preparing the example project. To prepare this, I started a new project by creating a folder called JavaScript Prime. I added a file called package.json with the JavaScript Prime folder and added the configuration. The packages that are specified in the package.json file include polyfill libraries that add support for essential features to older JavaScript browsers, a JavaScript module loader, and the Bootstrap CSS frameworks. The tools required to use TypeScript to generate JavaScript file are also included. Now creating the HTML and JavaScript file. I created a file called primer.ts in the JavaScript Prime folder and added the code. This is just a placeholder to get the project started. The HTML file includes a script element that loads a file called prime.js. This file does not exist yet, but the TypeScript compiler will generate it when it processes the primer.ts file. Now configuring the TypeScript compiler. The TypeScript compiler requires a configuration file that specifies how it should generate JavaScript file. I created a file called tsconfig.json in the JavaScript primer folder and added the configuration. I explain what each configuration setting does. It is enough to just create the file. Now running the example project. Once you have created all the required files, run command to start the TypeScript compiler and the development HTTP server. A new browser tab or window will open and display the content of the index.html file. Open the browser's F12 developer tools, so called because they are typically opened by pressing the F12 key, and look at the JavaScript console. The JavaScript console shows the result of the call to the console.log function. Rather than show a screenshot of the browser's JavaScript console for each example. And that's it, the example project for running. And that's it for the lecture. Thank you for watching. Hello everyone, welcome to the course. In this lecture, I am telling you about understanding the script element. JavaScript code is added to an HTML document using the script element. The src attribute is used to specify which JavaScript file should be loaded. The name of the file loaded by this element is primer.js. When using the TypeScript compiler, there is an indirection relationship between the files that contain the JavaScript code that you write and the files that are loaded by the browser. This can be an awkward transition to make if you are used to writing JavaScript file directly, but it allows the TypeScript compiler to translate the most recent features from the JavaScript specification into code that will run on the older browsers. Now using a JavaScript module loader, manually keeping track to set of files and making sure that the HTML file contains the correct set of script elements is an error-prone process. You are likely to add a script element that includes a file with the .ts extension rather than its .js counterpart, or forget to add a script element for a new file. It is also hard to correctly order the script elements. Browsers execute the content of JavaScript file in the order defined by the script elements. in the HTML document, and it is easy to create a situation where code in the file loaded by one script element depends on functionality loaded by another script element that the browser has yet to load. Managing the JavaScript content in an application can be simplified by using a module loader, which takes responsibility for detecting and resolving dependencies between JavaScript files, loading them, and ensuring their content are executed in the right order. The package.json file I created at the start of the include that system module loader. I explain how to create JavaScript modules and how the system.js module loader is used in where I also use it to load Angular and some of the libraries it depends on. The most important change in the listening is this statement. Now understanding the basic workflow. To understand the way that the different workflow steps relate to one another, add a statement to the primer.ts file. When you save the change to the primer.ts file, the process will occur. Number 1. The TypeScript compiler will detect the change to the primer.ts file and compile it to generate a new prime.js file that can run in any browser. The development HTTP server detects the change to the primer.js file and signals the browser to reload the HTML document. The browser reloads the HTML documents and starts processing the elements it contains. It loads the JavaScript files specified by the script element in the HTML document, including those for the JavaScript module loader. The JavaScript module loader processes its configuration and asynchronously requests the primer.js file from the HTTP server. Now, using a statement. The basic JavaScript building block is the statement. Each statement represents a single command, and statements are usually terminated by a semicolon. The semicolon is optional, but using them makes your code easier to read and allows for multiple statements on a single line. The browser execute each statement in turn. In this example, all the statements simply write message to the console. Now, defining and using function. When the browser receives JavaScript code, either directly through a script element or indirectly through the module loader, it executes the statements it contains in the order in which they have been defined. This is what happened the previous. The module loader loaded the primer.js file and the statement it contains were executed one by one, all of which wrote a message to the console. You can also package statements into a function, which will not be executed until the browser encounters a statement that invokes the function. Defining a function simple. Use the let keyword followed by the name you want to give the function. followed by the equal sign and the function keyword, followed by parentheses. The statements you want the function to contain and enclosed between wheres. In the listening, I use the name my function, and the function contain a single statement that write a message to the JavaScript console. Now define function. There are two ways in which you can define function in JavaScript. The approach I used in listening is known as a function expression. The same function can console also be defined. This is known as a function declaration. The result is the same, a function called my function that writes a message to the console. The difference is how the functions are processed by the browser when a JavaScript file is loaded. Function declarations are processed before the code in a JavaScript file is executed, which means you can use a statement that calls a function before it is defined. This works because the browser finds the function declaration when it passes the JavaScript file and sets up the function before the remaining statements are executed. That's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about defining functions with parameters. JavaScript allows you to define parameters for functions. I added two parameters to the my function called name and weather. JavaScript is a dynamically typed language, which means you do not have to declare the data type of the parameters when you define the function. I will come back a dynamic type when I cover JavaScript variable. Now, using default and reset parameters, the number of arguments you provide when you invoke a function does not need to match the number of parameters in the function. If you call the function with fewer arguments than it has parameters, then the value of any parameters you have not supplied valued for it undefined, which is a special JavaScript value. If you call the function with more arguments then there are parameters, then the additional arguments are ignored. The consequence of this is that you cannot create two functions with the same name and different parameters and expect JavaScript to differentiate between them based on the arguments you provide when invoking the function. This is called polymorphism, and although it is supported in languages such as Java and C#, it is not available in JavaScript. Instead, if you define two functions with the same name, then the second definition replaces the first. There are two ways that you can modify a function to respond to a mismatch between the number of parameters it defines and the number of arguments used in both it. Default parameters deal with the situation where there are fewer arguments than parameters and allow you to provide a default value for the parameters for which there are no arguments. The rest parameter must be the last parameter defined by the function, and its name is prefixed with an ellipsis. The rest parameter is an array to which any extra arguments will be assigned. Now defining function that return result. You can return result from function using the return keyword. Function defines one parameter and uses it to produce a result. I invoke the function and pass the result as the argument to the console.log function. Notice that you do not have to declare that the function will return a result or denote the data type of the result. Now using function as arguments to other functions. JavaScript functions can be passed around as objects, which means you can use one function as the argument to another, as demonstrated. The my function defines a parameter called name function that it invokes to get the value to insert into the string that it returns. I pass a function that returns Adam as the arguments to my function, which produce output. Function can be chained together, building up more complex functionality from a small and easily tested pieces of code. Now using arrow function. Arrow function, also known as fat arrow functions or lambda expression, are an alternative way of defining function and are often used to define functions that are used only as arguments to other functions. This function performs the same work as the ones in listening. There are three parts to an arrow function: the input parameter, then an equal sign and a greater than sign, and finally the function result. The return keyword or curly braces are required only if the arrow function needs to execute more than one statement. There are more arrow function in this lecture. Now using variables and types. The let keyword is used to declare variables and optionally assign a value to the variable in a single statement. Variables declared with let are scoped to the region of code in which they are defined. There are three statements that use the let keyword to define a variable called message. The scope of each variable is limited to the region of code that it is defined. This may seem like an odd example, but there is another keyword that can be used to declare variables: var. The let keyword is a relatively new addition to the JavaScript specification that is intended to address some addition in the way var behaves. The problem is that the var keyword creates variables whose scope is the containing function, which means that all the references to message are referring to the same variable. This can cause unexpected results for even experienced JavaScript developers and is the reason that the more conventional let keyword was introduced. You are free to use let or var in Angular development. And this is the using variables and types I am now covering. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, I am telling you about routing basics. You can think of a SPA as a collection of states such as home state, product details, state and shipping state. Each state represents a different view of the same SPA. So far, the online auction has only one view state, the home page. The online auction has a navigation bar on top, a search form on the left, and a footer at the bottom, and you want these components to remain visible all the time. The rest of the page consists of a content area that displays the auction courses 1 and several auction product component. You will reuse this content area for displaying different views based on the user's action. To do this, you will need to configure the router so it can display different views in the outlet, replacing one view with another. This content area is represented by the tag router outlet. You will be assigning a component for each view that you want to display in this area. You did not create a parent component that would encapsulate the carousel and auction product, but by the end of this, you will refactor the code to create a home component to serve as a parent of the carousel and product. You will also product detail component to represent each product's detail. At any given time, the user will see either home component or product detail component in the router underscore outlet area. The router is responsible for managing client-side navigation, and we will provide a high-level overview of what the router is made up of. In the non-SPA world, site navigation is implemented as a series of requests to a server which refreshes the entire page by sending the appropriate HTML documents to the browser. With SPA, the code for rendering component is already on the client, and you just need to replace one view with another. Now, location strategies. At any given time, the browser's location bar displays the URL of the current view. A URL can contain different parts. It starts with a protocol followed by a domain name, and it may include a part number. Parameters that need to be passed to the server, a question mark. Changing any character in the preceding URL results in a new request to the server. In SPAS, you need the ability to modify the URL without making a server-side request, so the application can locate the proper view on the client. Angular offers two location strategies for implementing client-side navigation. Hash location strategy. A hash sign is added to the URL, and the URL segment after the hash uniquely identifies the route to be used as a web page fragment. These strategies work with all browsers, include the old ones. Path location strategy. This history API based strategy is supported only in browsers that support HTML5. This is the default location strategy in Angular. A sample URL that uses hash based navigation. Changing any character to the right of the hash sign does not cause a direct server side request, but navigates to the view represents by the path after the hash. The hash sign serves as a separator between the base URL and the client side location of the required content. Try to navigate a SPA like a Gmail and watch the URL for the inbox it look. Now go to the sent folder and the hash portion of the URL will change from inbox to sent. The client-side JavaScript code invokes the necessary function to display the send view. But why does the Gmail app still shows you the loading message when you switch to the send box? The JavaScript code of the send view can still make AJAX requests to the server to get the new data, but it does not load any additional code, markup or CSS from the server. The browser's history API allows you to move back and forth through the user's navigation history as well as programmatically manipulate the history stack. Manipulating the browser history in the Mozilla Developer Network. Consider the URL http://mysite.com 8080 product/page/3. The product/page/3 URL segment can be pushed to the base URL programmatically without using the hashtag. If the user navigates from page 3 to 4, the application code will push product/page/4, saving the previous product/page/3 state in the browser. Angular spares you from invoke push state explicitly. You just need to configure the URL segments and map them to the corresponding component. With the history API based location strategy, you need to tell another how to use as a base URL in your application, so it can properly append the client-side URL segment. You can do it in one of two ways. Add the base tag to the header of index.html such as base hrefr. Assign a value of the app base here Angular constant in the root module and use it as a provider's value. And that's it for the lecture. Thank you for watching. Hello everyone, welcome to the course. In this lecture, I am telling you about running the sample application. Typically, the code that comes with each has several sample applications. To run a particular application, you will need to make a one-line change in the configuration file of system.js to specify the name of the main script that you want to run. To run this application using the code that comes with, make sure that the main script that bootstraps your root module is properly mapped in systemjs.config.js. The same applies to the other sample application in this and other. The main script of this application is located in the main.ts file in the directory samples. To run this app, make sure that the systemjs.config.js file lists main.ts in the app package and then start the live server from the project root directory. Now systemjs and on the fly transpiling. TypeScript offers an elegant declarative syntax for implementing many Angular features. Including routing, we use syntax.js in our code samples, and the transpiling of TypeScript into JavaScript is done on the fly when the application code is loaded into the browser. But what if the application does not work as expected? If you open the developer tools panel in other browser, you will see that each file with the extension .ts has a corresponding .ts transpiled file. This is a transpiled version of the code that may be handy if you need to see the actual JavaScript code that runs in the browser. Angular comes with a location class that allows you to navigate to an absolute URL by invoking its go, forward and back methods, along with some others. Location should be used only if you need to interact with the URL outside of the Angular router. Now navigation to routes with navigate. In the basic underscore routing code example in the section, you arrange the navigation using router link in HTML and code tags. But what if you need to arrange navigation programmatically without asking the user to click a link? Let's modify that code sample to navigate by using the navigate method. You will add a button that will also navigate to the product detail component. By this time, no HTML and codes will be used. Listening will invoke the navigate method on the router instance that will be injected into the root component via its constructor. For simplicity, you place the module and routes declaration, the bootstrap and the app component in the same file. But in real world projects, you should keep them separate as you did in the section. Now, handling 404 errors. If the user enters a non-existent URL in your application, the router will not be able to find a matching route and will print an error message on the browser's console, leaving the user to wonder why no navigation is happening. Consider creating an application component that will be displayed whenever the application cannot find the matching component. For example, you could create a component named underscore 404 component and configure it. Now whenever the router cannot match the URL to any component, it will render the content of underscore 404 component instead. You can see it in action by running the application main with 404.ts that comes. Just enter the non-existent URL in the browser. Now passing data to routes. The basic routing application showed how you can display different components in a predefined outlet on the window. But you often need not only to display a component but also to pass some data to it. If you navigate from the home to the product detail route, you need to pass the product ID to the component that represents the destination route, such as product detail component. The component that represents the destination route can receive passed parameters via its constructor arguments of type activated route. Beside the passed parameters, activated route stores the route's URL segment, the outlet. Now extracting parameters from activated route. When the user navigates to the product detail route, you need to pass the product ID to this route to display details for the particular product. Let's modify the code of the application in the section so root component can pass the product ID to product detail component. The new version of this component will be called product detail component param, and Angular will inject an object of type activate route into it. The activate route object will contain the information about the component loaded. The activate route object will contain all the parameters that are being passed to the component. You just need to declare the constructor's argument specifying its type, and Angular will know how to instantiate and inject this object. In listening 3.8, you will change the configuration of the product route and route link to ensure that the value of the product ID will be passed to the product detail component param component if the user chooses to go this route. This new version of the app is called main param.ts. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about the dependency injection and inversion of control patterns. Design patterns are recommendation for how to solve certain common tasks. A given design pattern can be implemented differently depending on the software you use. In this section, we will briefly introduce two design patterns, a dependency injection and inversion of control. Now, the dependency injection pattern. If you have ever written a function that takes an object as an argument, you can say that you wrote a program that instantiated this object and inject it into the function. Imagine a fulfillment center that ships products, an application that keeps track of shipped products can create a product object and invoke a function that creates and saves a shipment record. The create shipment function depends on the existence of an instance of the product object. In other words, the createShipment function has a dependency product, but the function itself does not know how to create product. The calling script should somehow create and give this object as an argument to the function. Technically, you are decoupling the creation of the product object from its use, but both of the preceding lines of code are located in the same script, so it is not real decoupling. If you need to replace product with mock product, it is a small code change in this simple example. What if the createShipment function had three dependencies and each of those dependencies had its own dependencies? In that case, creating a different set of objects for createShipment would require many more manual code changes. Would it possible to ask somehow to create instances of dependencies for you? This is what the dependency injection pattern is about. If object A depends on an object of type B, object A will not explicitly instantiate object B. Rather, it will have B injected from the operational environment. Object A just needs to declare, I need an object of type B. Could someone please give it to me? The words of type are important here. Object A does not request a specific implementation of the object and will be happy as long as the injected object is of type B. Now the inversion of control pattern. Inversion of control is a more general pattern than DI. Rather than making your application use some API from a framework, the framework creates and supplies the objects that the application needs. The IOC pattern can be implemented in different ways, and DI is one of the ways of providing the required object. Angular plays the role of the IOC container and can provide the required objects according to your component's declaration. Now, benefits of dependency injection. Before we explore the syntax of Angular's implementation of DI, let's look at the benefit of having objects injected versus instantiated them with a new operator. Angular offers a mechanism that helps with registering and instantiating component dependencies. In short, DI helps you write code in a loosely coupled way and makes your code more testable and reusable. Say you have a product component that gives product detail using the product service class. Without DI, your product component needs to know how to instantiate the product service class. This can be done multiple ways, such as using new calling get instance on a singleton object or invoking create product service on some factory class. In any case, product component becomes tightly coupled with product service. If you need to reuse product component in another application that uses a different service to get product details, you must modify the code. DI allows you to decouple application components by sparing them from the need to know how to create their dependencies. In Angular application, you register object for DI by specifying providers. A providers is an instruction to Angular about how to create an instance of an object for future injection into a target component or directive. Angular uses the concept of a token, which is an arbitrary name representing an object to be injected. Usually, the token's name matches the type of the object to be injected. So the preceding code snippet instructs Angular to provide a product service token using the class of the same name. Using an object with the property provide, you can map the same token to different values or object of the product service while someone else is developing a real service class. Now that you have added the provider's property to the add component annotation of product component, Angular's DI module will know that it has to instantiate an object of type product service. Product component does not need to know which concrete implementation of the product service type to use. It will use whatever object is specified as a provider. The reference to the product service object will be injected via the constructor's arguments. And there is no need to explicitly instantiate product service in products component. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about injectors and providers. Now that you have had a brief introduction to dependency injection as a general software engineering design pattern, let's go over the specifics of implementing DI in Angular. In particular, we will go over such components as injectors and providers. Each component can have an injector instance capable of injecting objects or primitive values into a component or service. Any Angular application has a root injector available to all of its modules. To let the injector know what to inject, you specify the provider. An injector will inject the object or value specified in the provider into the constructor of a component. Although eagerly loaded modules do not have either own injectors, a lazy loaded module has its own subroot injector that's a direct child of the application root injector. Providers allow you to map a custom type to a concrete implementing of this type. You can specify the providers either inside the components at component decorator or as a property of at ng module, as in every code sample so far. In Angular, you can inject data only via a constructor's arguments. If you see a class with a no argument constructor, it is a guarantee that nothing is injected into this component. You will be using product component and product service for all the code samples in this If your application has a class implementing a particular type, you can specify a provider object for this class during the app module bootstrap. Now injection with TypeScript versus ES6. TypeScript simplifies the syntax of injection into a component because it does not require you to use any DI annotations with the constructor arguments. All you need to do is specify the type of the constructor's argument. This works because any component has an annotation at component, and because the TypeScript compiler is configured with the option emit decorator metadata true, Angular will automatically generate all required metadata for the object to be injected. Because you use syntax system JS for on-the-fly TypeScript transpiling, you can add the TypeScript compiler option in systemconfig.js. The provide property maps the token to the method of instantiating the injectable object. This example instructs Angular to create an instance of the mock product service class wherever the product service token is used as a dependency, but the object creator can use a class, a factor function, a string, or a special class for instantiation and injection. Now, how to declare a provider? To map a token to an implementation of a class, use the object with the useClass property. If you have a factor function that instantiates object based on certain criteria, use an object with the useFactory property, which specifies a factory function that knows how to instantiate required objects. The factory function fat arrow that knows how to instantiate required object. The factory function can have an optional argument with dependencies if they exist. To provide a string with a simple injectable value, use the object with the useValue property. Now a sample application with Angular DI. Now that you have seen a number of code snippets related to Angular DI, let's build a small application that will bring all the pieces together. We want to prepare you for using DI in the online auction application. Now injecting a product service. Let's create a simple application that uses product component to render product details and product service to supply data about the product. If you use the downloadable code that comes with this app is located in the main basic.ts file in the di_samples directory. You will build an application that procedures the page. App module bootstrap app component, which includes product component, which is depend on product service. Note the import and export statements. The class definition of product service starts with the export statement to enable other components to access its content. Product component includes the import statement providing the name of the class and the module being imported. The provider attribute defines on the component level instructs Angular to provide an instance of the product service class when requested. Product service may communicate with some server requesting details for the product selected on the web page, but we will skip this part of now and concentrate on how this service can be injected into product component. Now injecting the help service. Often a service will need to make an HTTP request to get the requested data. Product component depends on product service which injected using the Angular DI mechanism. If product service needs to make an HTTP request, it will have an HTTP object as its own dependency. Product service will need to import the HTTP object injection at ng module must import HTTP module which define HTTP providers. The product service class should have a constructor for injecting the HTTP object. And that's it for the lecture. Thank you for watching. Hello everyone, welcome to the course. In this lecture, first I am telling you about data binding. Data binding allows you to connect the data from your application with the UI. The data binding syntax lowers the amount of manual coding. Briefly introduce the data binding syntax, and you used it in almost every example in the lecture. In Angular, data binding is implemented in a unidirectional way. The one way could mean either applying data changes from the component's properties to the UI or binding UI events with the component's method. For example, whenever a component's product title property is updated, the view is automatically updated by using the syntax in the template product title. Similarly, when a user type in an input field, the event binding invokes an event handler on the right side of the equal sign. In template, both double curly braces in the text and square bracket in HTML elements attributes result in property binding. Angular binds the interpolated value string with injected expression value to the text content property of the corresponding DOM node. Now, what is wrong with AngularJS two-way binding? In AngularJS, data changes on the view automatically updated the underlying data, which also triggers an update of the view. In other words, Angular.js uses two-way data binding under the hood. Although having two-way data binding in forms simplifies coding, using it to bind values in various application scripts may substantially slow performance in large application. That is because Angular.js internally keeps a list of all data binding expression on the page, and a browser event can result in Angular.js checking the list of the expression over and over again until it ensures the everything in the sign. During this process, a single property can be updated multiple times. Although Angular does not use two-way data binding by default, you can still implement it. Now it is your choice. Note the frameworks. We will go over several flavors of data binding. Event binding to invoke a function that handles this event. Attribute binding to update the text value of an HTML element's attribute. Property binding to update the value of the DOM element's property. Template binding to transfer the view template. Two-way data binding with ng model. Now, binding to events. To assign an event handler function to an event, you need to put the event name in parentheses in the components template. When the event specified in parentheses is triggered, the expression in double quotes is re-evaluated. In the preceding example, the expression are functions, so they are invoked each time the corresponding event is triggered. If you are interested in analyzing the properties of the event object, add the seventh argument to the handler function. In particular, the target property of the event object represents the DOM node where the event occurred. The instance of the event object will be available only within the binding scope. Now, binding to properties and attributes. Each HTML element is represented by a tag with attributes, and the browser creates a DOM object with properties for each tag. The user sees DOM object on the screen as they are rendered by the browser. You should have a good understanding of what exists at any given moment in three distinct areas: the HTML documents, the DOM object, the rendered UI. As HTML document consists of elements represented by tags with attributes, which are always string, the browser instantiates HTML elements as DOM objects that have properties and are rendered on the web page as a UI. However, the values of the DOM node's properties change, the page is re-rendered. Now, when property binding is used. Property binding is used in these two scenarios. A component needs to reflect the state of the model in the view. A parent component needs to update a property of its child. We use the word attributes in the context of the HTML document. Attribute bindings are rarely used because the browser uses HTML to build the DOM tree. After that, it works mainly with properties of the DOM object. But there are some cases when you may need to use attribute bindings. For example, the hidden attribute is not supported in Internet Explorer 10 and it would not create a corresponding DOM attribute. So if you need to toggle the visibility of a component using CSS styles, attribute binding will help. Another example is integration with the Google Polymer framework. You can only do it via attribute binding. Like property binding, an attribute binding is denoted by placing an attribute name in a square bracket. But to let Angular know that you want to bind to an attribute, you have to add the prefix attr. Now simplifying code with destructing. In Appendix A, we will cover the ES6 distracting feature, which is also supported by TypeScript. Distracting could simplify the code of the event handler function. The onInput event function receives the event object and then a line extract the value from the target property. With distracting syntax, you can eliminate the line that extracts the value of event.target. Using the curly braces in the argument of this function is spent instructing to the function. That's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about binding in templates. Say you need to conditionally hide or show a certain HTML element. You can do so by binding a boolean flag to a hidden attribute or a display style of the element. Depending on the flag's value, this element will be either shown or hidden. But the object that represents this element remains in the DOM tree. Angular offers structural directives that changes the DOM's structure by removing elements from or adding elements to it. ngIf can conditionally remove an element from or add on to the DOM tree. ng for loops through an array and adds an element to the DOM tree for each array element. ng switch adds an element to the DOM tree from a set of possible elements based on some condition. Using template binding, you can instruct Angular to do this for you. Removing elements can be better than hiding them if you want to ensure that your application will not waste time supporting the behavior of this element. Now HTML templates and Angular directives. The HTML template tag in the Mozilla Developer Network documentation is not a typical tag because the browser ignores its content unless the application indicates a script to parse and add it to the DOM. Angular offers so-called shortcut syntax for directives. They start with an asterisk such as *ngIf or *ngFor. When Angular parser sees a directive that start with an asterisk, it converts this directive into an HTML fragment that uses a template tag and is recognizable by browsers. Indicates one span and one template and illustrates two flavors of template binding using the ngIf directives. Depending on the flag's value, the span elements either add to the DOM or remove from it. Unlike other Angular binding, the template binding transforms the view template. The code in listening pipe to conditionally adds the message about the flag's value to or removes it from the DOM tree. Now, two-way data binding. Two-way data binding is a simple way to keep the view and the model in sync. Whether the view or the model change first, both are immediately synchronized. You have learned that one-way binding from the UI to an Angular component is arranged by surrounding an event name with parentheses. One-way binding from a component to the UI is denoted by surrounding an HTML. In some cases, you may still want to use two-way binding. the longer way of combining the two preceding examples. Angular also offers a shorter combine notation. In particular, Angular has a ng model directive that you can use for two-way binding. You can still see my component property, but which event does it handle? In this example, the ng model directive is used with the input element. This event is the default trigger for synchronizing UI changes in the HTML input element with the underlying model. But the driving event can be different depending on the UI control being used with ng model. This is controlled internally by a special control value accessor Angular interface which serves as a bridge between a control and a native element. Control value accessor is used to create custom form controls. Two-way binding was popular with forms where we needed to synchronize values from the form fields with the properties of underlying model object. Now, reactive programming and observable. Reactive programming is about creating responsive event-driven application where an observable event stream is pushed to subscriber. In software engineering, observer or observable is a well-known pattern, and it is a good fit in any asynchronous processing scenario. But reactive programming is a lot more than just an implementation of the observe or observable pattern. The observable streams can be cancelled. They can notify about the end of a stream, and the data pushed to the subscriber can be transformed on the way from the source to the subscriber by applying various operators. Now, what are observable and observes? An observer is an object that handles a data stream pushed by an observable function. There are two main types of observable, hot and cold. A cold observable starts streaming data when some code invokes a subscriber function on it. A hot observable streams data even if there is no subscriber instead in the data. A script that subscribers to an observable provides the observer object that knows what to do with the stream element. To be precise, an observable stream knows how to do three things: emit the next element, throw an error, send a signal that the streaming is over. Now, from arrays to iterable and observable. JavaScript has a number of useful methods for working with arrays of data, such as this. Map allows you to apply a function to each element of the array. With map, you can transform one array into another without changing the number of elements. Filter allows you to apply a function to each element of an array, filtering out elements by applying some business logic. Reduce allows you to produce an aggregate value from an array's element. A stream is a collection of data given to your application over time. ES6 introduced the concept of iterable and iterators that let you treat an array as a data collection and iterate through its element on a time. That's it for the lecture. Thank you for watching. Hello everyone. Welcome back to the course. In this lecture, first I am telling you about observable event streams. Each event is represented by the event object containing properties describing the event. Angular applications can handle standard DOM events and can create and emit custom events as well. A handler function for an event can be declared with an optional servant parameter that contains a JavaScript object with properties describing the event. With standard DOM events, you can use any functions or properties of the browser's event object. In some cases, you will not be interested in reading the event object properties, such as when the only button on the page is clicked and this is all that matters. In other cases, you may want to know specific information, such as what character was entered in the input field when the key-up event was dispatched. The preceding code sniffs accessing the value property of the input element by using event.target, which points at the element that dispatches the event. But Angular allows you to get the HTML element right in the template by declaring a template local variable that will always hold a reference to its HTML element. The code fragment declares a mySearch field local template variable, extract the value of the hosting HTML element, and passes it to the event handler function rather than the reference to the event object. Note that the hash sign is needed only to declare a local variable in the template. You do not need the hash when using this variable in the JavaScript portion of the code. If your code dispatches a custom event, it can carry application specific data and the event object can be strongly typed. A traditional JavaScript application treats a dispatches event as a one-time deal. For example, one-click result in one function invocation. Angular offers another approach when you consider event observable stream of data happening over time. Handling observable stream is an important technique to master. So let's see what it's all about. By subscribing to a stream, your code expresses an interest in receiving the stream's elements. During subscription, you specify the code to be invoked when the next element is emitted, and optionally the code for error processing and stream completion. Often you will specify a number of chained operations and then invoke the subscriber method. How does all this apply to event coming from the UI? You could use event binding that handles multiple key-up events and handles the value of last stock symbol. Is not this technique good enough for handling multiple events? Imagine that the preceding code is used to get a price quote for the APL stock. After the user types the first A, the getStockPrice function will make a promise-based request to the server, which will return the price of A. If there is such a stock, then the user enters the second A, which results in another server request for the A price quote, the process repeats the AAP and AAPL. This is not what you want, so you can arrange a 500 millisecond delay to give the user enough time to type several letters. The set timeout function comes to the rescue. What if the user types slowly and during the 500 millisecond interval manages only to enter AAP? The first request for AAP goes to the server, and 500 milliseconds later the second request for AAPL is sent. A program cannot cancel the first HTTP request if the server returns a promises object. So you will keep your finger crossed that your users type quickly and do not overload the server with unwanted requests. Now cancelling observable. One of the benefits of observable over promises is that the former can be cancelled. We offered one scenario in which a typo might result in useless server request. Implementing master detail views in another use case for a request cancellation. Say a user click in row in a list of product to see the product detail that must be retrieved from the server. Then they change their mind and click another row with issue another server request. In that case, the pending request should ideally be cancelled. Let's look at how you can cancel pending request by creating an application that issues HTTP as the user type in the input field. You will handle two observable streams. Number 1, the observable stream produced by the search field. Number 2, the observable stream produced by the HTTP request issued while the user is typing in the search field. Now pipes. A pipe is a temporal element that allows you to transform a value into a desired output. A pipe is sacrificed by editing the vertical bar and the pipe name right after the value to be transformed. Angular comes with a number of predefined pipes, and each pipe has a class that implements its functionality, as well as the name you can use in the template. Uppercase pipe allows you to convert an input string into uppercase by using uppercase in the template. Data pipe lets you display a data in different format by using data. Currency pipe transforms a number into a desired current by using currency. Assign pipe will unwrap the data from the provided observable stream by using assign. Some pipes do not require input parameter and some do. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about intercomponent communication. A view that consists of a number of components that are numbered and have different shapes for easier reference. Some of the components contain other components and other are pairs. To abstract this from any particular UI framework, we avoided using HTML elements like input fields, drop-downs and buttons, but you can explorate this into a view of your real-world application. When you design a view that consists of multiple components, the less they know about each other, the better. Say a user clicks the button in component 4, which has to initiate some actions in component 5. It is possible to implement this scenario without component knowing that component exists. You have seen already examples of loosely coupling components by using dependency injection. Now, input and output properties. Think of an Angular components as a black box with outlets. Some of them are marked as at input and others are marked as at output. You can create a component with as many inputs and outputs as you want. If an Angular component needs to receive values from the outside world, you can bind the procedures of these values to the corresponding inputs of the component. Whom are they received from? The component does not have to know. The component just needs to know what to do with these values when they are provided. If a component needs to communicate values to the outside world, it can emit events through its outputs. Whom are they emitted to? The component does not have to know. Whoever is interested can listen or subscribe to the event that a component emits. The input properties of a component are decorated with that input and are used to get data from the parent component. Imagine that you want to create a UI component for placing orders to buy stocks. It will know how to connect to the stock exchange, but that is irrelevant in the context of this discussion of input properties. You want to ensure that order component receives data from other component by its properties marked with at input and notation. You will also pass quantity to the order component, but you will not use binding with quantity. So you can see the case when a parent needs to pass to the child a value that will not be changing. You will leave off the binding mechanism by not surrounding the quantity attribute in the order processor tag with a square bracket. Because you do not use binding for the quantity attribute, the value 100 arrives in order component as a string. If you want to preserve the types using binding, if you change the value of a stock symbol or quantity in the order component, the change will not affect the property values of the parent component. Property binding is unidirectional from parent to child. The next question is, how can component intercept the moment when one of its input property changes? A simple way is to change the input property to a scatter. You use a stock symbol in the template of the component, so you need the getter as well. Because you have a public setter, rename the variable to underscore stock symbol and make it private. When this application starts, all input variables are initialized with the default values, and the change detection mechanism qualifies the initialization as a change of the bound variable stock symbol. The setter is invoked, and to avoid sending an order for the undefined stock symbol, you check its value in the setter. Angular component can dispatch custom event using the event emitter object. This event can be handled either in the component or by its parent. Event emitter is a subclass of subject that can serve as both observable and observer. In other words, event emitter can dispatch custom event using the emit method as well as consume observable using its subscribe method. Because this section is about sending data from a component to the outside world, we will focus on dispatching custom events here. Now, event bubbling. As we write this, Angular does not offer a syntax to support event bubbling. For price quoter component, this means if you try to listen to the last price, even not on this component but on its parent, the event will not bubble up there. If event bubbling is important to your application, do not use event emitter, use native DOM events instead. Price quoter component that handle event bubbling without using Angular's event emitter. In the preceding application, Angular injection a reference to the DOM element that respects price quoter using element refer and then the custom event in dispatched by invoking element.native element.dispatch event. Event bubbling will work here, but keep in mind that this code becomes browser specific and will not work with non-HTML renders. Now the mediator pattern. When you design a component-based UI, each component should be self-contained, and components should not rely on the existence of other UI components. Such loosely coupled components can be implemented using the mediator design pattern, which according to Wikipedia defines how to set of object interact. Imagine a child playing with bubbling bricks that do not know about each other. Today this child can use some blocks to build a house, and tomorrow they will construct a boat from the same component. The role of the mediator is to ensure that components properly fit together according to the task at hand while remaining loosely coupled. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about an alternative implementation of mediator. In this lecture, you show how sibling components use their parent as a mediator. If components do not have the same parent or are not displayed at the same time, you can use an injectable service as a mediator. However, the component is created, the mediator service is injected, and the component can subscribe to event emitted by the service. If you had liked to see this in action, read the providing search result to home component section in the hand-on exercise. Check the code of the product service that plays the role of the mediator. This service defines the search event emitter variable, which is used by search component to emit the data entered by the user. Home component subscribes to the search event variable to receive the text entered by the user in the search form. Now changing templates at runtime with ng content. In some cases, you will want to be able to dynamically change the comment of a component's template at runtime. In AngularJS, this was known as transclusion, but the new term for it is projection. In Angular, you can project a firm get of the parent component's template onto its child by using the ng-content directive. The syntax is pretty simple and required two steps. In the child component templates, include the tag. In the parent component, include the HTML fragment that you want to project into the child's insertion point between tag representing the child component. We will also use the example to illustrate how the shadow DOM and Angular views encapsulation work. Have you noticed that both parent and child components use the .wrapper style in their outmost div elements? In a regular HTML page, this would mean both parent and child would be rendered with the same style. We will show that it is possible to encapsulate a style in child component so that do not conflict with parent style if their names are the same. Note that the .wrapper style from the parent's type was not applied to the child div, also using the .wrapper style which is rendered in a light green background. The child shadow root acts as a well protecting the child's style from inheriting the parent style. Now, component lifecycle. Various events happen during the lifecycle of an Angular component. When a component is created, the change detection mechanism begins monitoring the component. The component is initialized, added to the DOM, and rendered so the user can see it. After that, the state of the component may change, causing re-rendering of the UI, and finally the component is destroyed. The user sees the component after the initialization phase is complete. Then the change detection mechanism ensures that the component's properties stay in sync with its UI. If the component is removed from the DOM tree as a result of the router's navigation or structural directives, Angular initiates the destroy phase. The constructor is invoked first when the instance of the component is being created, but the component's properties are not initialized yet in the constructor. Now, when not to write code in constructor. In the online auction application, you inject product service in the constructor of home component and invoke the getProducts method right here. If the getProducts method needed to use values of the component properties, you had moved the invocation of this method to ng-on-init to ensure that all properties were initialized by the time you called getProducts. To other reasons to move code from the constructor to ng-on-init is to keep the constructor code light without listing any long-running synchronous function from there. Now, using ng-on changes. Let's illustrate components lifecycle hooks using ng-on changes. These examples will include parent and child components, and the latter will have two input properties, greeting and user. The first property is a string and the second is an object with one property name. To understand why the ng-on change callback may or may not be invoked, you need to be familiar with the concept of mutable versus immutable object. Now, mutable versus immutable. JavaScript strings are immutable, which mean when a string value is created in memory, it will never change. The first line created the value hello at a certain memory location, such as at 287651. The second line does not change the value at that address but created the new string hello Mary at a different location, such as 286777. Now you have two strings in memory and each of them is immutable. What happened to the variable getting? Its values changed because it pointed initially at one memory location and then to another. JavaScript objects are mutable, which means after the object instance is created at a certain memory location, it stays there even if the values of its property changes. After the first line, the object is created and the user variable points at a certain memory location, such as at 277500. The string John has been created at another memory location, such as at 287600, and the user.name variable stores the reference to this address. After the second line is executed, the new string Mary is created at another location, such as 287700, and the user.name variable stores the reference to this new address, but the user variable still stores the memory address at 277500. That's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about template driven versus React approaches. In a template driven approach, forms are fully programmed in the components template. The template defines the structure of the form, the format of its field, and the validation rules. In contrast, in a reactive approach, you create the form model programmatically in the code. The template can be either statically defined and bound to an existing form model or dynamically generated based on the model. You will be familiar with the Angular Forms API and the various ways of working with forms and applying data validation. Now, overview of HTML forms. HTML provides basic features for displaying forms, validating entered values, and submitting the data to the server. But HTML forms may not be good enough for real-world business applications which need a way to programmatically process the entered data, apply custom validation rules, display user-friendly error message, transform the format of the entered data, and choose the way data is submitted to the server. For business applications, one of the most important considerations when choosing a web framework is how well it handles forms. We will evaluate standard HTML form features using a sample user registration form, and we will define a set of requirements that a modern web application needs to fulfill users' expectation. Now, standard browser features. You may be wondering what you need from an application framework other than data binding. If HTML already allows you to validate and submit forms. To answer this question, let's review an HTML form that uses only standard browser features. The form contains a button on the 4 input fields: username, SSN, password, and password confirmation. Users can enter wherever values they want. No input validation is applied here. When the user clicks the submit button, the forms values are submitted to the server's endpoint using HTTP post, and the page is the default HTML from behavior is not a good fit for a SPA, which typically needs the functionality, that is, validation rules should be applied to individual input field. Error messages should be displayed next to the input field that causes the problems. Dependent fields should be validated altogether. These forms have passed and password confirmation field, so whenever either of them is changed, both fields should be revalidated. The application should be in control of the value submitted to the server. When the user clicks the submit button, the application should invoke an event handler function to pass the from values. The application can validate the values or change their format before sending the submit request. The application should decide how the data is submitted to the server, whether it is a regular HTTP request, an AJAX requested, or a WebStock message. HTML validation attribute and semantic input types partially satisfy the first two requirements. Several standard validation attributes allow you to validate individual input fields: required, pattern, max length, min, max, step, and so on. You use a regular expression to restrict when can be entered in this field. When the user clicks the submit button, the form will be validated before the submit request is sent. There are a number of problems with this message, that is, it is too vague and does not help the user identify and fix the problem. As soon as the input field loses focus, the error message disappears. This message format likely will not match other styles in the application. This input field prevents users from submitting invalid values, but it does not let you provide a decent user experience by helping the user with friendly client-side validation. Now, enabling Forms API support. Now, Angular's Forms API. There are two approaches to working with forms in Angular: template driven and reactive. These two approaches are exposed as two different APIs in Angular. With the template driven approach, the form model is defined in the components template using directives. Because you are limited to the HTML syntax while defining the form model, the template driven approaches suits only simple scenario. Now, enabling Form API support. Both type of forms, template driven and reactive, need to be explicitly enabled before you start using them. To enable template driven forms, add Forms module from Angular or Forms to the import list of the ng module. The user the forms API. For reactive forms, use reactive from module. Now template driven forms. As we mentioned earlier, you can use only directives to define a model in the template driven approach, but what directive can you use? Directive comes with from module, ng model group and ng from. Now directives overview. We will briefly describe the three main directives from module, ng model group and ng from. ng from is the directive that represents the entire forms. It is automatically attached to every element. ng from implicitly created an instance of the from group class that represents the model and store the from data. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about enriching the HTML from. Let's refactor the simple user registration from listing 7.1. There it was a plain HTML from that did not use any Angular features. Now you will warp it into an Angular component, add validation logic and enable programmatic handling of the submit event. Let's start by refactoring the template and then move on the TypeScript part. First modify the from element. You declare a local template variable f and points at the ng from object attached to the from element. You need this variable to access the from's properties such as values and valid, and to check whether the forms has errors of a specific type. You also configure the event handler for the submit event emitted by ng from. You do not want to listen to the standard submit event and ng from intercept the submit event and stop its propagation. This prevents the from beginning automatically submitted to the server, resulting in a page reroute. Instead, ng from emits its own ng submit event. The onSubmit method is the event handler. It is defined as the component instance method. In template driver forms, onSubmit takes on argument the form's value, which is a plain JavaScript object that gives the values of all the fields on the form. Next, you change the username and SSN field. Now, reactive forms. Unlike in the template driven approaches, creating a reactive form is a two-step process. First, you need to create a model programmatically in the code, and then you link HTML elements to that model using directives in the template. Now, from model. The from model is an underlying data structure that keeps the form's data. It is constructed out of special classes defined in the add Angular or forms module, from control, from group and from array. From control is an automatic from unit. Usually it corresponds to a single input element, but it can also represent a more complex UI component like a calendar or a slider. From control keeps the current value of the HTML element it corresponds to, the element's validity status, and whether it has been modified. From group usually represents a part of the from and is a collection of from controls. From group aggregates the values and the statuses of each from control in the group. If one of the control in a group is invalid, the entire group becomes invalid. It is convenient for managing related field on the from. From group is also used to represent the entire from. For example, if a data range is represented by two data input fields, they can be combined into a single group to obtain the data range as a single value and display an error if either of the enter details is invalid. Now from directives. The reactive approach uses a completely different set of directives than template driven forms. The directives for reactive form come with reactive forms module. All reactive directives are prefixed with the from integer string, so you can easily distinguish the reactive from the template driven approach just by looking at the template. Reactive directives are not exportable, which means you cannot create a variable in the template that references an instance of a directive. This is done intentionally to clearly separate the two approaches. In template driven forms, you do not access the model classes, and in reactive forms, you cannot operate the model in the template. Now, property binding shortened syntax. Because the value you assign to the name directive is a string literal, you can use the shortened syntax and omit the square bracket around the attribute name. Note that a square bracket around the attribute name and single quotes around the attribute value. Let's continue the example of the data range model introduced when we explained the from group name directives. The component and from model remain the same. You only need to complete the template. As in the from group name directive, you just specify the name of a from control you want to link to the DOM element. Again, these are the names you choose while defining the from model. From control can be used for single field forms when you do not want to create a from model with from group but still want to use forms API features like validation and the reactive behavior provided by the from control. Value change property. Now refactoring the sample from. Now let's refactoring the sample registration from for listening 7.1. Originally it was a plain HTML form and then you applied a template driven approach. Now it's time for a new Reactive version. You start a reactive form by defining a from model. The from model property gives an instance of the from group type that defines the structure of the from. You will use this property in the template to bind the model to the DOM element with the from group directives. And that's it for the lecture. Thank you for watching. Hello everyone, welcome to the course. In this lecture, I am telling you about a brief overview of the HTTP Objects API. Web applications run HTTP requests asynchronously, so the UI remains responsive and the user can continue working with the application while the HTTP requests are being processed by the server. Asynchronous HTTP requests can be implemented using callbacks, promises, or observable. Although promises eliminate the callback hell, they have the shortcoming that is, there is no way to cancel a pending request made with a promise. When a promise resolves or rejects, the client receives either the data or an error message, but in either case, it will just be a single piece of data. A promise does not offer a way to handle a continuous stream of chunks of data delivered over time. Observables do not have this shortcoming. We looked at a promise-based scenario that resulted in multiple necessary requests to get a price quota for a stock, generating unnecessary network traffic. Then in the example with the weather service, we demonstrated how you can cancel HTTP request made with observable. Let's look at the Angular implementation of the HTTP class, which is included in the @Angular or HTTP package. This package includes several classes and interface as described in the Angular HTTP client documentation. Now, what's the Fetch API? There is an effort underway to unify the process of fetching resource on the web. The Fetch API can be used as a replacement for the XML HTTP request object. It defines generic request and response object which can be used not only with HTTP but also with other emerging web technologies like service workers and the Catch API. To extract the body's content from the response, you need to use one of the methods in the response object. Each method expects the body to be in a certain format. You read the body as plain text using the text method, which it returns a promise. Unlike Angular's observable-based HTTP service, the Fetch API is promise-based. The Fetch API is mentioned in Angular documentation because several Angular classes and interfaces are inspired by its. Now, creating a web server with Node and TypeScript. Many platforms allows you to develop and deploy web server. We decide to use Node.js for the reasons that is, there is no need to learn a new programming language to understand the code. Node allows you to create a standalone application. Node does a great job in the area of communication using HTTP or web stacks. Using Node lets you continue writing code in TypeScript, so we do not have to explain how to create a web server in Java, .NET or Python. In Node, a simple web server can be written with a few lines of code, and you will start with a very basic one. Then you will write a web server that can serve JSON data using the HTTP protocol. A bit later, you will create yet another version of the server that will communicate with the client over a WebStock connection. Now creating a simple web server. You will create a standalone Node application that will run as a server supporting all the Angular code examples. When both the server and client sliders are readly, the projector's directory will have the structure. If you have run the code sample from appendix, you already have the TypeScript compiler installed on your computer. Let's start by creating a directory named http underscore websocket underscore samples with a server subdirectory. After running the nmp run tsc command, the transfiled hello underscore server.js file will be saved in the build directory, and you can start your web server. Now TypeScript 2.0 and add types. In this project, you use a locally installed TSC compiler version 2.0, which uses the add types package to install type definition files. That's because older version of TSC did not support the types compiler option, and if you have an older version of TSC installed globally, running TSC will use the version, causing compilation errors. To ensure that you use the local version of TSC, configure it as a command in the scripts section of package.json and start the compiler by entering the nmp run tsc command to transfile the server's file. Run this command from the same directory where the tsconfig.json file is located. Now serving JSON. In all the auction code samples so far, the data about products and review has been hard-coded in the product services.ts file as arrays of JSON formatted object. In the hands-on section, you will move this data to the server. So the Node web server needs to know how to serve JSON. To send JSON to the browser, you need to modify the header to specify a meme type of application or JSON. The snippet suffices as an illustration of sending JSON, but real-world servers perform more functions such as reading file, routing, and handling various HTTP requests. Later in the auction example, you will need to respond with either product or review data depending on the request. To minimize manual coding, let's install Expression, a Node framework that provides a set of features required by all web applications. That's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about live TypeScript, recomplication and code reload. The server-side examples are written in TypeScript, so you need to use TSC to transfile the code to JavaScript prior to deploying it in Node. To set the auto completion mode for your code, open a separate command window in the directory with the sources and run the command. When no file names are specified, TSC uses the tsconfig.json file for compilation option. Now, wherever you make a change in the TypeScript code and save the file, it will generate a corresponding .js file in the build directory and specified in tsconfig.json. Live compilation of the TypeScript code helps, but the Node server will not automatically pick up code changes after it has started, so that you do not need to manually restart the Node server to see your code changes in action. You can use a handy utility, NodeMon. It will monitor for any changes in your source, and when it detects changes, will automatically restart your server and reload the code. Now, adding the RESTful API for serving products. Your ultimate goal is to serve products and reviews for the auction application. In this section, we will illustrate how to prepare a Node server with REST endpoints to serve products in JSON format when HTTP GET required are received. You will modify the code in the myexpressserver.ts file to serve either all products or a specific one. The modified version of this application shown next is located in the auction REST server.ts file. Now you can start the auction REST server.ts application in Node and see if the browser received all product or a selected product. Now bringing Angular and Node together. Earlier you created the http_web socket_samples folder containing the auction REST server.ts file, which is a Node application that responds to HTTP GET request and supplies product details. In this section, you will write an Angular client that will issue HTTP request and treat the product's data as an observable object returned by your server. The code of the Angular application will be located in the client subdirectory. Now, a static resource on the server. A typical web application deployed on the server includes a static resource that have to be loaded in the browsers when the user enters the application's URL. Because we are using system.js, which does on the fly transpiling, the TypeScript files are a static resource as well. From Node's perspective, the Angular portion of this application is considered a static resource because Angular apps load dependencies from node_module. This directory also belongs to the static resource required by the browser. The Express framework has a special API to specify the directories with a static resource, and you will make slight modification in the auction REST server.ts file. In the file you did not specify directory with a static resource because no client's app was deployed there. Let's give the same REST endpoints on the server, that is /server main.html, which is the landing page of the application. Products gets all products. Products.id gets a product by its ID. Unlike in the my_express_servers.ts application, you do not want Node to handle the base URL. You want Node to send the main.html file to the browser. Now npm scripts. npm supports the scripts property in package.json with more than a dozen scripts available right out of the box. You can also add new commands specific to your development and development workflow. Some of these scripts needs to be run manually and some are invoked automatically. In general, if any command in the script section starts with the post prefix, it will run automatically after the command specified after this prefix. For example, if you define the command post install my custom install.js, each time you run npm install, the my custom install.js script will run as well. Similarly, if a command has a prefix, the command will run before the command named after this prefix. Now, common versus separate configuration files. All code samples for the client and server belongs to a single npm project and share the same package.json file. All dependencies and typing are shared by the client and server applications. This setup may reduce the time for installing dependencies and save a space on disk because some of the dependencies may be shared between the client and server. But keeping the code for the client and server in a single project tends to complicate the build automation process for two reasons. Number one, client and server may require conflicting versions of a particular dependency. Number two, you use blind automation tools which may require different configuration from client and server, and their node_module directories would not be located in the root directory of the project. And that's it, the common versus separate configuration file. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about getting to know Jasmine. Jasmine allows you to implement a behavior-driven development process which suggests that test of any unit of software should be specified in terms of the desired behavior of the unit. With BDD, you use neutral language constructs to describe that you think your code should be doing. You write unit test specifications in the form of short sentence such as application component is successfully instantiated or stars component emits the rating change event. Because it is so easy to understand the meaning of the test, they can serve as your program documentation. If other developers need to become familiar with your code, they can start by reading the code of the unit test to understand your intentions. Using natural language to describe test has another advantage. It is easy to reason about the test results. As much as we had liked all of our tests to pass, make a habit of ensuring that your test fails first and see if the test results are easy to understand. In Jasmine terminology, a test is called a spec and a combination of one or more spec is called a suite. A test suite is defined with the describe function. This is where you describe what you are testing. Each test spec in the suite is programmed as an it function which defines the expected behavior of the code under test and how to test it. Now, where to store test files. The Jasmine framework is used to unit test JavaScript applications written in different frameworks or in pure JavaScript. One of the approaches for storing test files is to create a separate test directory and keep only test scripts there, so they are not mixed up with the application code. In Angular applications, we prefer to keep each test script in the same directory as the component or service under test. This is convenient for two reasons. Number one, all component related files are located together in the same directory. Typically, we create a directory for storing the components .ts, .html and .css files. Adding a .spec file there will not clutter the directory content. Number 2, there is no need to change the configuration of the system.js loader, which already knows where the application file are located. It will load the test for the same location. Now, what to test? Now that you have an understanding of how to test, the question is what to test. In Angular application written in TypeScript, you can test function, classes and component. Test function. Say you have a function that converts the passed string to uppercase. You can write multiple tests just for this function. For cases where the argument is null, an empty string, undefined, a lowercase word, an uppercase word, a mixed case word, a number and so on. Test classes. If you have a class containing several methods, you can write a test suite that includes all the tests needed to ensure that each of the class methods functions properly. Test components. You can test the public API of your service or components. In addition to testing them for correctness, we will show your code samples that use publicly exposed properties or methods. Now, how to install Jasmine? You can get Jasmine by downloading its standalone distribution, but you will install it using npm as you have done for all other packages. The npm repository has several Jasmine related packages, but you just need Jasmine code dot. Open the command window in the root of your project. To make sure the TypeScript compiler knows about the Jasmine type, run the command to install the Jasmine type define file. When your tests are written, you need a test runner application to run them. Jasmine comes with two runners. One is for the command line and the other is HTML based. Now using the stand alone Jasmine distribution. If you want to see the running Jasmine test quickly, download the zip file with the standalone version of Jasmine from http github.com/jasmine/release. Unzip this file and open specrunner.html in your web browser. You will also need to add all required Angular dependencies as you did in every index.html file in all the code samples in the lecture, plus the Angular testing library. You will keep using the system.js loader, but this time you will load the code of the unit test, which will load the application code via import statements. In this lecture, we will show you how to write unit test. You will run them manually using the HTML based runner first. Then we will show you how to use Karma, which can run command line test the report possible errors in different browsers. Now what comes with Angular's testing library? Angular comes with a testing library that includes the wrappers for Jasmine's describe it and exit function, and also add such functions as before it, assign, fake assign and other. Because you do not configure the bootstrap the application during test runs, Angular offers a test-bed helper class that allows you to declare modules, component, providers and so on. Test-bed includes such function as configure test tick module, create component, inject and other. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about testing service. Typically, Angular services are injected into component. We set up the injectors. You need to define providers for an it block. Angular offers the before each setup method, which runs before each it call. You call inject the service into it using inject to test synchronous function in the service. Real service may need some time to complete, and this may slow your test. There are two ways to speed up test. Number 1, create a class that implements a mock service by extending a class of the real service that return hard-coded data quickly. For example, you can create a mock service for weather service that return immediately without making any request to the remote server that returns actual weather data. Using the fake assign function, which automatically identifies asynchronous calls and replaces timeouts, callbacks and promises with immediately executed functions. The tick function allows you to fast forward the time, so there is no need to wait until the timeout expires. Now testing navigation with the router. To test the router, your spec scripts can invoke such router methods as navigate and navigate by URL. The navigate method takes an array of configured routes that will construct the route as an argument, whereas navigate by URL takes a string representing the segment of the URL you want to navigate to. If you use navigate, you specify the configured path and route params, if any. If the router is properly configured, it should update the URL in the address bar of the browser. The next code snippet shows how to programmatically navigate to the product route. Pass 0 as a route param and ensure that after the navigation, the URL has a segment of product. When you provide an array of values to the router, it is called a command API. Now, testing components. Components are classes with templates. If your class contains methods implementing the application's logic, you can test them as you would any other functions. But more often you will testing the templates. In particular, you are interested in testing the binding work properly and that they display the expected data. Angular offers the testbed.createComponent method, which returns a component fixer object that will be used to work with the component when it is created. This fixture gives you access to both the component and the native HTML elements instances, so you can assign values to the component's properties as well as find specific HTML elements in the component's template. You can also trigger the change detection cycle on the components by invoking the detectChange method on the fixture. After the change detection has updated the UI, you can run the expect function to check the rendered values. Now, testing a sample weather application. Let's try testing Angular components and services using an application that has a main page with two links, home and weather. You will use a router to navigate to the weather page, which is a refactored version of the weather app you created. A large chunk of the code was placed in the constructor of app component, which complicates testing because you cannot invoke the code of the constructor after an object is created. Now, weather component will get the weather service injected, and weather service will use the remote server to get the weather information. Now, configuring system.js. To use an HTML-based test runner, you need to add Angular testing modules to your system.js configuration. The fragment from the system.js.config.js file that comes with the project. Now, testing the weather router. The router for this application is configured in the app.routing.ts file. Although you can configure the route either in your app module or in a separate file, having the routes configured in a separate file is a best practice. Doing so allows you to reuse the route configuration to run both the application and the test script. The script in app.module.ts of the weather apps use the routes constant in the declaration of at ng modules. Now testing the weather service. The weather service class encapsulates communication with the weather service. Note that use of the Paku token type mentioned, you use it twice to inject into URL base and URL suffix the value provided in the ng model director. Using dependency injection for URL base and URL suffix makes it simpler to replace the real weather server with a mock if need be. The getWeather method in listing 9.6 forms the URL of the HTTP get by concatenating URL base, city and URL suffix. The result is processed by map, filter and another map, so the observable will emit object of type weather result. You are not testing the underscore hash result and underscore parse data method because private method can be unit tested. Should you decide to test them, change their access level to public. To test weather service, you will use the mock backed class, which is one of Angular implementation of the HTTP object. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about template driven versus reactive approaches. In a template driven approach, forms are fully programmed in the components template. The template defines the structure of the form, the format of its fields, and the validation rules. In contrast, in a reactive approach, you create the form model programmatically in the code. The template can be either statically defined and bound to an existing form model or dynamically generated based on the model. By the end of this, you will be familiar with the Angular Forms API and the various ways of working with forms and applying data validation. Now overview of HTML forms. HTML provides basic features for displaying forms, validating entered values and submitting the data to the server. But HTML forms may not be good enough for real-world business application which need a way to programmatically process the entered data. Apply custom validation rule, display user-friendly error message, transform the format of the entered data and choose the way data is submitted to the server. For business application, one of the most important consideration when choosing a web framework is how well it handles forms. We will evaluate a standard HTML form feature using a sample user registration form, and we will define a set of requirements that a modern web application needs to fulfill users' expectation. We will also look at the form feature provided by Angular. Now, standard browser features. You may be wondering what you need from an application framework other than data binding. If HTML already allows you to validate and submit forms, to answer the question, let's review an HTML form that uses only standard browsers feature. The form contains a button and 4 input fields: username, SSN, password, and password configuration. Users can enter whatever values they want. No input validation is applied here. When the user clicks the submit button, the forms values are submitted to the server's register endpoint using HTTP post and the page is refreshed. The default HTML from behavior is not a good fit for a SPA, which typically needs the functionality, that is, validation rules should be applied to individual input fields. Error message should be displayed next to the input field that caused the problem. Dependent fields should be validated altogether. This form has past and past confirmation fields, so whatever either of them is changed, both fields should be revalidated. The application should be in control of the values submitted to the server when the user clicks the submit button. The application should invoke an event handler function to pass the from value. The application can validate the values or change their format before sending the submit request. The application should decide how the data is submitted to the server, whether it is a regular HTTP request, an AJAX request, or a WebSocket message. Several standard validation attributes allow you to validate individual input field, required pattern, max length, mean, max, step, and so on. For example, you can request the username be a required field and its value should contain only letters and numbers. Here you use a regular expression to restrict what can be entered in the field. When the user clicks the submit button, the form will be validated before the submit request is sent. Now Angular's Forms API. There are two approaches to working with forms in Angular: template driven and reactive. These two approaches are exposed as two different APIs in Angular. With the template driven approach, the form model is defined in the component's template using directives. Because you are limited to the HTML syntax while defining the form model, the template driven approach suits only simple scenario. For complex form, the reactive approach is a better option. With the reactive approach, you create an underlying data structure in the code. Now enabling Forms API support. Both type of forms, template driven and reactive, need to be explicitly enabled before you start using them. To enable template driven forms, add forms module from @Angular or forms to the imports list of the ng module that uses the Forms API. For reactive forms, use reactive form module. Here to how to do it. We will not repeat this code for each example, but all of these assume the models are imported. All the downloadable code samples for the book import the modules in app module. Now template driven forms. As we mentioned earlier, you can use only directives to define a model in the template driven approaches. But what directives can you use? These directives comes with from module, ng module group and ng forms. We discuss how the ng model directive can be used for two-way data binding, but in the Forms API it plays a different role. It marks the HTML element that should become a part of the from model. Although these two roles are separate, they do not conflict and can be safely used at the same time on the single HTML element. You will see example in this section. Let's briefly look at these directives and then apply the template driven approach to the sample registration form. And that's it for the lecture. Thank you for watching. Hello everyone, welcome back to the course. In this lecture, first I am telling you about directives overview. Here we will briefly describe the three main directives from module, ng model group and ng from. We will show how they can be used in the template and highlight their most important features. ng from is the directive that represents the entire from. It is automatically attached to every from element. ng from implicitly creates an instance of the from group class that represents the model and stores the from's data. ng from automatically discovers all child HTML elements marked with the ng model directives and adds these values to the from model. The ng from directive has multiple selectors that you can use to attach ng from to non-element. This syntax comes in handy if you are using a CSS framework that requires a certain structure for the HTML elements and you cannot use the from element. First you specify ng froms as the value of the export as property of ng from. A point at the instance of ng from attached to the from. Then you can use the f variable to access instance members of the ng from object. One of them is value, which represents the current value of all froms fields as a JavaScript object. You can pass it through the standard JSON pipe to display the from's value on the page. The code subscribes to the ng submit event using the event binding syntax. On submit is an arbitrary name for the method defined in the component and it is invoked when the ng submit event is fired. To pass all of the from's values as an argument to this method, use the f variable to access ng from's values properly. Now enriching the HTML from. Let's refactor the sample user registration from listing 7.1. There it was a plain HTML from that did not use any Angular features. Now you will warp it into an Angular component, add validation logic and enable programmatic handling of the submit event. Let's start by refactoring the template and then move on to the TypeScript part. You declare a logical template variable f that points at the ng froms object attached to the from element. You need this variable to access the from's properties such as value and valid and to check whether the from has error of a specific type. Now reactive froms. Unlike in the template driven approach, creating a reactive froms is a two-step process. First, you need to create a model programmatically in the code, and then you link HTML elements to that model using directives in the template. Let's start with the first step, creating a model. Now from model. The from model is an underlying data structure that keeps the from's data. It's construct out of special classes defined in the @Angular or forms module, from control, from group and from array. From control is the atomic from unit. Usually it corresponds to a single input element, but it can also represent a more complex UI component like a calendar or a slider. From control keeps the current value of the HTML element it corresponds to, the element's validity status, and whether it is been modified. From group usually represents a part of the from and is a collection of from controls. From group aggregates the values and the status of each from control in the group. If one of the controls in a group is invalid, the entire group becomes invalid. It's convenient for managing related fields on the from. From group is also used to represent the entire from. For example, if a data range is represented by two date input fields, they can be combined into a single group to obtain the data range as a single value and display an error if either of the interdates is invalid. Now from directives. The reactive approach uses a completely different set of directives than template driven forms. The directives for reactive forms comes with a reactive forms module. All reactive directives are prefixed with the from integer string, so you can easily distinguish the recharge reactive from the template driven approach just by looking at the template. Reactive directives are not exportable, which means you cannot create a variable in the template that references an instance of a directive. This is done intentionally to clearly separate the two approaches. In template driven forms, you do not access the model classes, and in reactive forms, you cannot operate the model in the template. The first column lists the model classes covered in the section. In the second column are the directives that bind a DOM elements to an instance of a model class using the property. Binding syntax. As you can see, from array cannot be used with the property binding. The third column lists directives that link a DOM element to a model class by name. Now property binding. Shorthand syntax. Because the value you assign to the name directive is a string literal, you can use a shortened syntax and omit the square bracket around the attribute name. Note that a square bracket around the attribute name and single quotes around the attribute value. From control name must be used in the scope of the from group directives. It links one of its child from control instance to a DOM element. And that's it, the property binding shorthand syntax. That's it for the lecture. Thank you for watching. Hello everyone, welcome to the course. In this lecture, first I am telling about refactoring the sample from. Now let's refactor the sample registration from listing 7.1. Originally it was a plain HTML form and then you applied a template driven approach. Now it is time for a reactive version. You start reactive forms by defining a model from. The from model property keeps an instance of the from group type that defines the structure of the from. You will use this property in the template to bind the model to the DOM element with the from group directives. It is initialized programmatically in the constructor by instantiating model classes. The names you give to from controls in the parent from group are used in the template to link the model to the DOM elements with the from control name and from group name directives. Password group is a nested from group to group the password and password confirmation fields. It will be convenient to manage their values as a single object when you add from validation. Because reactive from directives are not exportable, you cannot access them in the template and pass the from's value directly to the onSubmit method as an argument. Instead, you access the value using the components property that holds the from's model. Now using from builder. From builder simplifies the creation of reactive forms. It does not provide any unique feature component to the direct use of the from control, from group and from array classes, but its API is more terse and saves you from the repetitive typing of class names. Let's refactor the component class from the section to use from builder. The template will remain exactly the same, but you will change the way the from model is constructed. Unlike from group, from builder allows you to instantiate from control is using an array. Each item of the array has a special meaning. The first item is from control's initial value. The second is a validation function. It can also accept a third argument, which is an assigned validation function. The rest of the array items are ignored. Now from validation. One of the advantages of using the forms API compared to regular data binding is that forms have validation capabilities. Validation is available for both types of forms, template driven and reactive. You create validators as plain TypeScript function. In the reactive approach, you use function directly, and in the template driven approach, you warp them into custom directives. Let's start by validating reactive forms and then move to template driven ones. We will cover the basic and apply validation to the sample registration form. Now validating reactive forms. Validators are just functions that conform to the interface. The validator function should declare a single parameter of type abstract control and return an object literal. There are no restrictions on the implementation of the function. It is up to the validator's author. Abstract control is the superclass for from control, from group and from array, which means validators can be created for all model classes. A number of predefined validatorship with Angular required mini length, max length and pattern. They are defined as static method of the validators class declared in the @Angular or forms module, and they match standard HTML5 validation attributes. Now the error object. The error returned by a validator is represented by a JavaScript object that has a property with the same name as the validator. Whether it is an object literal or an object with a complex prototype chain does not matter for the validator. The property's value can be of any type and may provide additional error details. The object has a top-level property that matches the validator's name, mini length. Its values is also an object with two fields, required length and actual length. These error details can be used to display a user-friendly error message. Not all validators provide the error details. Sometimes the top level property just indicates that the error has occurred. In this case, the property is initialized with the value true. Here is an example of the standard validators .require errors object. Now configure validators with from builder. Validators can also be configured when you are using from builder to define from models. Here is modified version of the model for the simple registration from that uses from builder. The Forms API supports asynchronous validators. Assign validators can be used to check from values against a remote server, which involves sending an HTTP request. Like regular validators, assign validators are function. The only difference is that assign validator should return either an observable or a promises object. The complete running application that illustrates how to use assign validators is located in the 08_assign validators.ts file in the code that comes. You are already familiar with the control properties such as valid, invalid and errors for checking field status.